Hello guys, welcome back to the channel. This is Rosario Borgesi, and in this video we will see how to create a DApp from scratch by using Wagmi and RainbowKit. In particular, we will create an application that means NFTs that will be stored on Pinata, and we will make use of RainbowKit to connect with our Metamask wallet, and also we will make use of Wagmi to send a transaction of Ether to another account, and also to interact with the smart contract. We will see how to write data to a smart contract, so in our case will be to mint NFTs, and also how to read data from a smart contract, so you will gain the knowledge that you have to create your own DApp. So let's get started. So let's start with an introduction on Wagmi. Why do we need Wagmi? As it is stated here, apps, decentralized app, so application that interact with the blockchain, need to support connecting wallets, multiple chains, signing messages and data, sending transactions, listening for events, state changes, refreshing the data of the blockchain, and so on and so forth. So how do we perform this operation when we are creating front-end applications? So how our React or Next.js application can interact with the blockchain and perform all those operations. And that is when Wagmi comes at our rescue. So Wagmi, it is basically a library based on TypeScript that provides us with the React hook that allow us to perform all these operations and so much more. So it basically provides the developers with the building blocks to build their own Ethereum applications. And it is important that this application, this library, Wagmi, is built on VM, which is a backend library that we use also to interact with the blockchain, and it is the most important library that you will need to write backend application that interact with the blockchain by using TypeScript. It is also important that important to say that Wagmi supports caching, deduplication, persistence, and also other features by using Tanstack query. What is Tanstack query? It is a library that Wagmi makes use of to enable to allow us to make simple the process of fetching, caching, synchronizing, and updating of asynchronous data in our React application. So as it is stated here, without an asynchronous data fetching abstraction, you would need to handle all the negative side effects that comes as a result, such as representing finite state, such as loading, error success, or for example handling race conditions, caching against a deterministic identifier, and so on. So all these operations are handled for us with Tanstack query that is included in Wagmi. So as we said earlier, Wagmi supports the most popular and commonly used Ethereum features out of the box, with 40 plus React hooks for accounts, wallets, contracts, transaction, signing, ENS, and more. There is also another feature that Wagmi provides, which is the possibility to connect with a wallet, because it is true that we want to perform all these operations on the blockchain, such as sending transaction, calling a smart contract, calling a function on the smart contract, but in order to perform all these operations, we need a library that allow us to connect with our wallet. And there are a series of third-party libraries that allow us to connect with a wallet using this connect wallet feature of Wagmi. So basically these third-party libraries implement this feature for us, or we can create this feature, this module of connect connect wallet module on our own, but this is not this will not be done in this video. So as it is said here, we have a lot of third-party libraries that allow us to connect to a wallet, which are, for example, ConnectKit, AppKit, RainbowKit, Dynamic, and Privy. In another video, in my channel, you can find the integration with Privy, which allows to also log in the user. In this video we will make use of RainbowKit, which is this library here, and as you can see, this library creates this pop-up that allow us to connect to multiple wallets, for example Rainbow, Coinbase Wallet, Metamask, Wallet Connect, Ledger Live, and so on and so forth. So this creates this pop-up, as we will see, that allow us to connect our wallet. So in our application we will use Metamask, but you can use all these kind of wallets that are listed here. From the RainbowKit page, let's go to the RainbowKit here in the documentation. Okay, now we can create our own application with RainbowKit, Wagmi, and Next.js. And to do that, we just we can use one of these lines here. So here I have already created a new folder, so I can open the terminal at this folder and run the command that we have seen earlier. Okay, to proceed, yes. What is the name of my project? Let's say RainbowKit underscore Wagmi tutorial. Okay, now it is installing the dependencies. So it has finished to install all the dependencies. Now we can change the directory to this this path here. Okay, and then we can type code dot that will open Visual Studio Code. Perfect. So this is this should be Next.js application. Let's see what we have. So we have this file that is our application. Okay, as you can see here, it has already imported the Wagmi provider that it is required when we want to use Wagmi. Okay, so we have the Wagmi provider. And inside it the query client provider. This is a Tanstack query. So also here as you can see from the Wagmi documentation, this is related to the setup of TAN-stack query. And then inside also we have another provider, which is the RainbowKit provider. And inside here we have this component here that should contain, I believe, the application. So this is the main page of our application that it has been created for us. Here we have the Wagmi configuration. Also keep in mind that the Wagmi, it is the library that allows us to interact with the blockchain, so send transaction, calling smart contracts, and RainbowKit is just a library that allows us to connect with the wallet. It is built on top of VM, so the main library, it is always VM. So here we are basically setting up the VM configuration. Here we are specifying the chain that we want to allow for our application. We will use base Evolia, which is a testnet, so we can just add here base Evolia, and it should be fine. As you can see here, all these imports of chains come from Wagmi. And from the documentation, I believe that here it talks about the possibility to add an RPC provider, because and we can do that by. So we could, for example, add a custom RPC provider here in this transport object. Otherwise, Wagmi will use a standard, a public RPC provider. The difference is that with an RPC provider provided, for example, by Alchemy, QuickNode, or Infura, we have fewer limits of requests that we can make. Instead, we are using a public node. We have a rate limit. Okay, so let's leave it this way for now. Let's see how it will play out. So let's just try to run this application. Let's see what happens. So let's execute npm run dev. Let's see what happens. So as you can see here, it's calling this is a Next.js application. Let's go here in the home page. Let's see what we will see. Okay, so this is the starting point of our application. If we here we hit connect the wallet, as you can see here, we can connect our wallet that we have, for example Metamask, Rainbow, also Coinbase wallet or Wallet Connect. So let's use the Metamask wallet that I have here. Okay, let's use for example another account like this one. Okay, if you don't have enough funds, you can always use the Coinbase faucet, or also other faucet. For example, in Fura, you can get some test it. So now it recognizes my recognize my account here with my balance here. Okay, let's see. It is taking the second address. Let's see if I can switch to the other one. Let's try to disconnect and reconnect. Let's see if it takes the right. Okay, now it's taking the right address, which is this one. Okay, now let's try to send some, for example, some Ether to another account. So I believe that we can cut. We can just leave this connect button here, and we can cut everything. Okay, maybe I leave here a div. Okay. Okay. Let's add, for example, a basic input. Let's start by adding a form. Okay, now we put an input. We say, for example, type number. Okay, placeholder. I don't need it. Let's create a state variable. Let's call it, for example, okay, use state. Okay, we should import the hook from React. Okay, now here we put value equal value. Okay. Okay, and now we can also put an onChange equals handle change. And so this function, this event handler, this should work. Yes. Let's maybe put here number. Here we put 0. Okay, now it seems fine. Let's add here, for example, label equal Ether. Okay. Okay, it seems that here does not support the label. Okay, let's write here, for example, something like and for example here Ether. Let's see what we will see on the screen. Okay, here we see basic input. So here was not taking the decimals, so I had to add here a parse float instead of parse int. We can also add, for example, the step here if we like, and now it will augment the number with the decimals. And now we can also add the recipient address. For example, here we put another label, we call it recipient, and we add another input. For example, here host recipient set. Okay, a string, that's fine. So let's say input recipient don't change set. This seems cool, seems okay. Maybe you could have wrote something similar here. For example, here write something like this. Seems better. Okay, now we have okay, maybe I wrote something wrong. Okay, here I'm missing a parenthesis. Okay, seems fine. Okay, recipient either. Fine, now it seems to work. Now we have to add the onSubmit on the form here. So we write on submit equal handle on submit, and here we write const handle on submit. Okay, this seems cool. Okay, here we write okay. So let's get back to the Wagmi documentation and see how we can send a transaction here. Okay. So here we need the hook use send transaction. So we can import this hook here. We can call it maybe here. Okay, here we can import it from Wagmi. Perfect. Then we can use the hook, as you can see here. Maybe I don't know if I forgot. No, it seems okay. Okay. So the to address in this case would be this one. Maybe it was better to call it to. Let's refactor it. Set. No, sorry, this is the value that we are sending. I was mistaken. So the to it is the recipient. So here we put the recipient. Okay, I should write okay, this is a 0x string, so we should put so here we need as 0x string. Now it should be fine. Okay, this is we must import this function from VM. as you can see, Wagmi, it is calling a VM function because Wagmi it is built on top of VM. Here we are calling this function because we want to convert Ether into Wei, okay? Because when we send a transaction to the blockchain, we always must send Wei. So here it does not like the number, so we could convert it to string. Maybe we just need to type dot to string. And it should be fine. So here we can type the recipient. Okay. Now we should add also here a button. Send Ether. Let's see what we have here in our application. Okay, here it is a button. Let's say that the recipient is we could also maybe console log the transaction. No, it returns void. We cannot do it. So let's take for example, I want to send money. We are on base Evolia on my fourth account. Let's copy this address. The amount of Ether I want to transfer is 0.001. Send Ether. Okay, here is calling Metamask. We must confirm the transaction. We confirm. Transaction confirmed. And here we can see the transaction on base scan. So we sent 0.001 from the first this account here, which is this one, to the second account, which ends with the 3DF. So the transfer was done correctly. So now that we have seen this, let's try a more advanced example. Let's see how we can interact with a smart contract. For example, let's see how we can mint an NFT, let's say. So in this page, which is the wizard of OpenZeppelin, we can create new smart contract. For example, in this case, we can create an ERC-721. Let's call it, for example, GTA vehicles, because we want to mint NFTs that contains GTA vehicles. Let's create it mintable. So auto increment ID. Okay, and that should be it. Okay, for us. So let's also add the URI storage. Okay, so we can set the URI of our new minted NFT that we can check then on, for example, on OpenSea. Okay, that seems to have everything. Let's copy this code. Okay, let's go on Remix, create, for example, a new file. Let's call it I have already one GTA vehicles. Let's call it GTA NFT .sol NFT. Okay. Let's paste this code here. So here it is a GTA NFT. Here the symbol, maybe it is just GTA. Okay, and so we can also change the Solidity version to a newer version here. So here we can deploy the smart contract. Let's say that we want to deploy it from my third account. Copy this address. Let's set injected provider. The address it's not no, it defaults to other two accounts. I don't know why. So it seems that I cannot use my third account here on Remix for some reason. So I will deploy this code with my second account. For example, here I remove the only owner, so anyone can deploy this contract here. Sorry, I should have I only need to remove the modifier only owner, so everyone can mint this NFT. Okay, let's try to let's call it GTA NFT. Okay, it seems fine. Now let's deploy. Let's remove also the owner. So there is no owner in this smart contract, we don't need it. Okay, it seems to be fine. So let's deploy this contract. Okay, let's confirm. Okay, so our smart contract has been deployed at this address here. So let's try to call this safe mint function here. So to here we need to write to a contract. So this is the part that we need to check, and it is similar to the one that we have done earlier. So here there is an example of minting an NFT. I would like to add a little bit of style before continuing, and it seems that this RainbowKit package does not come with Tailwind, so we need to add Tailwind in our application. We can do that firstly by running this command here. Let's close this since we are using so let's go here and let's install these dependencies. Okay, fine. Now the second step should be to run this. Okay, perfect. Now we need to add this file to tailwind.config.js. Okay, let's paste it here. We have to add this to our file globals.css. Let's create I don't know if it goes in the root. Let's create a new file here. .css. So I have added a little bit of CSS to our application, nothing special, but now we have a more cleaner view of our card. So now we can come back to the to our NFT that we want to mint with our application. We need to pass to the safe mint function the receiver and the URI. So we can add, for example, here another div like this in the bottom. And we can add another form. For example, we copy this form again. This should be this becomes handle submit transfer. Okay, so this should be changed as well. This becomes handle submit handle on submit mint. So we need to create another function here, const handle on submit mint. Okay, maybe better without this on. No, okay, no, doesn't matter. Okay, here we are going to no, first we need to here set another recipient. Okay, for this we have used this recipient, this variable here. Maybe we should change the name, recipient transfer recipient. Okay, this should be set transfer recipient, and this should be again. Okay, this seems to be fine. Transfer recipient, set transfer recipient. Okay, now in a similar manner you need to define const let's say mint recipient. Okay, and then we should define also the token URI. Okay, so on submit mint. Okay, this should be mint recipient. So here set mint recipient. Mint recipient. Okay. Okay. So here the input instead should be the token URI. So it must be something like token URI. Okay, type text. Here we put token URI. This set token Okay, here we leave this thing here. Okay, should be here we put mint NFT. Okay. Okay, perfect. Okay, in the meantime, I added a little bit more of CSS. I added this this text here and this other, and I placed the item one on top of the other. So now we should here on this handle on submit mint, which we could rename to handle sub. Okay, maybe also here handle submit transfer. So now we need to write to the contract. So the way to do it is this one. So we should first get this hook from Wagmi, and we also need the API. So let's create a new here a new folder. Let's call it lib. Let's create a new file called, for example, GTA NFT dot ts. Okay, we export a constant, for example GTA underscore NFT underscore ABI, which would be equal to export const, which would be equal to, we have here there was the autocompiler, but so the contract was already been compiled, but here you can copy the API of this contract. So we can put this constant here. Perfect. So this is the interface, the API that allows the Wagmi to interact with our smart contract deployed on the blockchain. So here we can start from importing this API. So we write something like import GTA. Okay, perfect. So we have the API. Now we need to add this hook here. Okay, so for example we can put it here. We import this from Wagmi. Actually we are not using maybe. Okay, maybe we could console log the transaction, but I don't know, for right now we don't need it. Let's call it hash, for example hash write. This is hash send, hash write tx, hash send tx. Okay, so now we imported our hook, then we need to call this function here when we submit the form. So basically Here we call e.prevent default, then we call this hook here. The address, it is the address of our where we have deployed our smart contract, which is this one. Okay, we can put it here. The API would be this. The function name is safemint. Okay, and as arguments we need to pass the receiver and the URI that are okay. Here we need to, so this is we set the receiver of our safemint function, so we have to put mint recipient as okay, and then token URI. That should be fine. Okay, I have to put here API column. Okay, now it works. Format document. That there should be everything, so we can try it. Okay, let's come back to our application. We want to mint to, for example, let's say this account. Okay, now for the token URI, I have already uploaded these files on Pinata. So if I go to Pinata and I log in, Pinata is a pinning service on IPFS. I will explain this how IPFS works on another video, but for now just know that I have uploaded this file here. So here you can see, for example, let's say 25 items. For example, this is the first vehicle that we want to deploy. This is a car of GTA 3. Now that image that we have seen earlier as an IPFS as an hash, a CID that has been placed inside this JSON that, as you can see, describes the NFT. So the name, the description here, it is the URL, the PFS URL of the image that we have seen earlier, plus some other attributes, because this is the standard that is supported by OpenSea, which is a marketplace where we will also find our NFTs once they have been minted. So to come back to our application, we need this URL here that contains the metadata of our NFT, because when we mint the NFT, we have also to associate to it an IPFS that will store our metadata. So now coming back to our application, which is here. So here we can simply write IPFS column / and we put that link here. So now it asks us to confirm the transaction. Okay, the transaction has been minted. So as you can see, it has been created the token of ID 0. This is the owner, and so it has been called the safe mint function. So it seems that everything went fine, and we could also, for example, try to read from a smart contract. So to read from a smart contract, we need to use another React, another Wagmi hook. In this case, use read contract. For example, in our NFT, we could, for example, call the token URI of the ID of ID 0. And so in order to do that, we need to import. We need first to import this new hook into our application. So we can paste it here. No, sorry, this is an import, so it goes here. Maybe we could also make it a little bit better. So we have imported the hook. Now let's get back here. We can call it this way. Maybe we would also put this thing here. Okay, use read contract. The function is I believe function is token URI. Okay, so we need to put here token URI. I don't know if it is okay, so with the capital letters. The argument we want to the token URI of, for example, the NFT of ID 0, and this would be this would be called token URI. No, let's say that we want to create an input. So as we have done until now, so let's create another state variable, for example const, let's say for example token ID. Okay, token ID. Okay, let's use a string. So here in the useRead contract, I have added the address, which is the contract address, and it is the same that we have placed here in this write contract function that I have extract into this string here, and the API like we did here. So this is a React hook that allow us to contact the function token URI, so we can get the token URI for a specific token ID. This token ID that we have here, which is a number, it will be the it is related to the input that we will put in our new form. So I have created this new form, which is very similar to the previous ones. I simply have put a new title here, and I have put here the new label token ID and this input field token ID with of type number, and here on the onChange obviously it calls set token ID, classic React code, and it is pretty much the same. The only difference is that here we are printing into the screen this token URI here, and this data, it is retrieved from the useRead contract hook. So at last the page will look like this. So as you can see, if I put here token 0, my token ID is this one. If I put 1, there is there is nothing, because we have minted only one NFT. Coming back to Pinata, here I have deployed, I have put 5 metadata for 5 different NFTs. So 5 different GTA vehicles, which are: the first one we have already seen, it is the Sentinel with his related JSON. Sorry, this is another JPEG. The related JSON is this one. Okay. IPFS URL, it is the same of the JPEG that we have uploaded here, and the same thing I have done for other 4 cars, which are this one, which is the Kuruma. Then there is the second, this is a train. Then we have the third car, which is the Banshee, and the 5th car, which is Mr. Whoopi. Maybe I forgot the 3rd car. No, okay. This is the 3rd. The 4th, so I missed this one. This is the Infernus. So we have 5 vehicles with related JSON file that describe the metadata or metadata of this NFT, and this is the standard that is recognized by OpenSea. So if we want our NFT to be recognized by OpenSea, we need to follow this standard here. So let's mint a new NFT. Let's mint the NFT number 1. So we need this metadata, this JSON metadata, and we go here. The recipient is always the same. Here we put this URL, so mint NFT. Okay, now we need to confirm the transaction. Okay, perfect, transaction confirmed. If I check for token 1, you can see that the token URI has been updated. Now let's mint also the second this 2.json. So we take this IPFS, we go to our page, we put it here, mint NFT. Okay. So NFT has been minted. We can always, of course, check the transaction. You can see token ID number 2 has been minted to this. This is my address, and has been called the safe mint function. Okay, so here always, you can find the token ID number 2. Then we can mint. I believe we are at token number 3. So let's take 3.json. Okay, copy. Let's put this here. Mint NFT. Confirm. Okay. And here we find also the new IPFS. Let's deploy also the 4th NFT. Okay, so it is updated. And then the last, which is number 5. So we copy this last JSON here, this last CID, sorry, mint NFT, confirm. Okay, it has been minted. We can find that this IPFS of token number 5. If we want, we could also test it on Remix, because here, for example, if I take the token URI of the token number 5, I find this URL, I can copy and paste it here, and it is the same. We could also, for example, check the balance of, for example, my account, which should be 6, right? And I believe that's it. The last thing that, for example, you can check, for example, owner of token 5. Okay, this is my account, correct? If I put 6, now I should find nothing. Okay, in fact it is execution reverted. Now we can go to OpenSea and see if our collection has been we can find our collection on OpenSea. We copy the address of our smart contract. Okay, you can see that here we can find all the 6 items of our collection, because OpenSea is an NFT marketplace, and it is used to sell NFTs. So here we can find our collection, and if you go, for example, in a specific and we check a specific NFT, we can check all the details that were that we put in our JSON file. So as you can see here, luxury supercar from GTA 3, here acceleration, driver train, top speed. These were all on the JSON metadata that we had uploaded before on IPFS with Pinata. Perfect. So guys, we have reached the end of the video. I hope that it has been useful. If you have any questions, please drop a comment below. And thank you for watching, and see you in the next video.